All right, welcome everyone. I think this room must be the unofficial testing track. Aji just gave a great talk in the session before about TDD as a treasure map. For those of you who didn't catch it, I would recommend checking that online when the talks are up. Today, we're going to be talking about why your test suite is making too many database calls. And the key problem we're trying to solve is slow tests. Slow tests are a problem because longer feedback loops, when we're writing code, slow down our development process as we're waiting for tests to run. Longer feedback loops also slow down deployment. If you're waiting on CI, that means that's 30 minutes, 60 minutes. You're waiting for a feature to go out, or even worse, a bug fix. And during that time, the site is down, your customers aren't happy. And then just generally, you get lower overall value from your tests because they are not running as frequently, and you're not as confident in your tests. So 3 things that are expensive in tests are HTTP requests, anything involving a headless browser, and database queries. And if you spent some amount of time in the Rails testing community, you've probably heard the following few pieces of performance advice. Firstly, disable real network calls. This can be done via tools like WebMock or VCR. And the idea is that the best way to not have slow tests because of HTTP requests is to not make them at all. Secondly, you'll often hear recommendations to organize your tests using the testing pyramid. In this architecture, you have a few expensive end-to-end tests that use those expensive headless browser requests. You'll have a medium amount of integration tests that test subsystems, and then a lot of cheap unit tests that test individual objects. And then finally, avoid persisting data when you don't need it. If you have a test like this one here that is testing that the full name method on a user will concatenate the first and last name, you don't need to go to the database for that. So instead of creating a user into the database, you might just create one in memory and assert it that way. So this is common advice that you'll hear around. If you're not already doing this, you probably want to be doing it in your test suite to start seeing some performance benefits. But today, I want to go deeper, particularly on the problem of database queries. And in your tests, when you set up data, the problem of setting up more data than you actually need. So making more inserts or updates to the database than the test actually requires. Now, it's worth noting that queries aren't that expensive. And so if you have one extra query in your test suite, it's fine. You're not going to notice it. The problem is when you have tens of thousands that accumulate over the course of a whole suite. That's when you're going to notice a significant difference. So the problem looks kind of like this. Right here, I've got an object graph. This is a little bit different than the class diagram you may be used to seeing that shows how different kinds of objects interact with each other. The object graph shows each individual instance in a particular system. And so if there's 2 instances of the same class, they're both going to show up here. And that's really nice for the kind of problems we're talking about today, because we care if there are more than one instance and if we're making more than one write to the database. Now, in this case, we're doing a unit test. We have one object, our system under test, we want to test. And somehow, we're also creating a couple of collaborators, and even a second-order collaborator. And then somehow, like way over on the edge there, there's some random extra object which has a random extra collaborator. And if all of those are writes to the database, we've now made 6 writes where we only needed 1. Multiply that over a full test suite, and you're starting to see some differences. Now you might say, I don't do unit tests. This whole testing and isolation thing, and mocks and stubs, that's brittle. I only do integration tests, so this is not a problem I have to worry about. And I have bad news for you, but you're going to have the exact same problem. It's just scaled up bigger. So now you're testing a whole subsystem, or maybe the system as a whole, using end-to-end tests. And Now the group of objects you're trying to test also have these random extra collaborators, second order collaborators, and we still somehow on the edge there have the random extra object and its collaborator. So it's just a lot of extra objects created into the database that we didn't need for our test. So how does this happen? Nobody sets out to write just busy work for their database to run at the same time as your test suite. Today we're going to dig into 3 locations in your code base where we tend to accidentally create more data than we meant to. Those are your test code, support code, and then the actual source code that is being tested. Starting with ways that your test code is making too many database calls. And a big culprit here is shared test setup. This is when you have test 1 and test 2, and they require some similar, but maybe not quite the same, data to be set up. And so you decide, hey, dry, I'm going to extract that out, put it into some kind of either a series of lets or maybe a before block, and that's going to be a way to share that setup. Unfortunately, what you tend to do is now you're creating all the data needed for test 1 and all the data needed for test 2 before each test. So you're creating the union of the two, and that means you're creating more data than you meant to. Here's an example. We have a test at the top that only requires an organization, and a test at the bottom that requires an organization with 2 users. Because of the way our lets are organized here, when we try to run the test that only needs the organization, it's going to also create 2 users. So we're going to be making 3 queries where we only needed 1. On an object graph, it might look like this. I shaded orange the data that we actually need for our test. That's the organization. And then we've created those extra users that we didn't mean to. So that's 2 extra objects. It's not that bad, but it doesn't scale well. Let's imagine a slightly more complex scenario. We have 4 tests, and each test needs 2 records. There's some sharing between tests, but none of them use the same 2 records. And across all of them, there are only 6 unique records. We've decided to extract all of them to shared setup. And if we model this as an object graph, we end up with something like this. So each row here is the object graph for one of our tests. And we can see it's the same set of 6 being created for each test, but each test only needs a different amount, yet we're still creating all 6. That's 24 insert queries where we only needed 8. But it gets worse even beyond that, because shared test setup often pushes us towards creating data that is not only extra, but sometimes the wrong shape for some of our tests. This can be because you end up wanting to do something that's kind of the average of all the tests that works for most of them, or that's close to what most of them want, but is not actually the data that all of them want. So here we have 2 tests, one of which at the bottom needs an admin user with a contact, and the one at the top only needs a regular user and doesn't care about the contact. The way things are set up here, our test that requires a regular user has to, well, first it's going to create a regular or an admin user and a contact. But because it doesn't want an admin user, it now has to issue an update to undo that admin flag and set it back to false. So now we're making 2 create queries, 1 update, and we only needed 1. Anytime you see update in test setup, that is a pretty major code smell. It typically means that something went wrong in your test setup, that somebody is setting up something earlier that you depend on that is just not in the right shape. It can also mean that there are issues in the underlying data model, and we'll get to that later. The solution is generally to move your setup inline. This is a little bit more verbose, but it means that each test only gets the data that it wants. Now, those of you who have been using RSpec for a long time are probably thinking, wait a minute, Let is lazy. Let is not going to create all that extra data, so we're fine. We don't need to do inline setup. And I had a whole section here that I had to cut about how let works versus let bang, and how laziness actually executes in a Rails test. But the summary of that is that in practice, lets are usually tangled together such that they will all end up being executed, and laziness doesn't come into play as much as we might hope it does. Now, it's possible to write your lets in such a way that they're not tangled, or they're only tangled in the way that's important, and that you don't create too much data. But that requires a lot of discipline on the part of a team, and in practice, I've always seen it fall apart. So my recommendation is do all of your setup inline, and that way you'll just avoid a whole class of errors. And that will scale better with your team. I know this is controversial, so if you have thoughts on this, come see me afterwards. I'd be happy to chat. So those are ways that you can avoid making those mistakes yourself. But we all work on existing code bases, and there's plenty of these issues already in our code. So how might we find them? This is difficult for tests because each individual little test is not creating that much extra data. It's the aggregate. And so you can't just find and change all of the tests at once. This is going to have to be a gradual thing, style that you introduce to your code base. And it's not something that's high value to change all the little ones that don't create all that much data. Instead, I'd encourage you to find tests that are slow and to then profile them. And that's the place where you're going to get value out of changing the way setup is done. Some tools that are really helpful. Rails logs all the queries to your test log anytime you run tests. And so what you can do is, if you have a slow test that you already know, you can run just that test or that group of tests or a file and tail the test log. And you can just see all the queries go by. And you might be surprised. It's a test that some other tool reports as slow. You're not sure why. And you tail the log and you see, oh, there are a lot of queries that get run, more than I expected. Or maybe you expect a lot of queries and there are not, and you know that this is not an area to prioritize. There's also a SQL tracker gem that you can run as a block around a particular test execution, and it will tell you how many queries are made. Moving on to ways that your support code is making too many database calls. A big offender here are factories that do too much. So here we have an organization factory, and it creates a list of 3 members for each organization whenever we create it. This can be tricky because you would have a very innocent looking test like this. It just says create organization. If I don't know what the factory says, I'm going to look at that and say, that makes 1 insert query. This test is not a problem. But actually, it's making 4 insert queries, the organization and those 3 users. Even worse, because factories call each other, expensive factories will compound in a pretty massive way. So we can see here a small example. We have our same organization as before that creates extra users. And we also have a user factory that has an association to the organization. If we have a test for some kind of service object, and again, we're just trying to give it a user, this will do a lot more work than we expect it to just looking at the test. Because that user factory is going to invoke the organization, and then the organization is going to create 3 more users. Don't worry, due to some ways that this is implemented, it's not infinitely recursive. But if it were, that would be even worse. But even just creating 4 extra records where we didn't mean to, that's a problem. And once you start having a larger data model with a lot of factories, this gets to be a giant tree that's created when you don't expect. So my advice here to you is your base factory should be minimal. And when I say minimal, I mean absolutely minimal. If there's a line in your factory that I can delete, and then it's still possible to create the factory without raising in the database, that line should be deleted. The only things that should be there are things that are required to pass Rails validations or to pass database constraints. So here's what a minimal factory might look like. We have our organization. We've taken out those extra users, but we've kept the name because there's a presence validation and it requires the name to be present. It's often very useful to have the users in our inline tests. We don't want to always be adding them inline because that's a lot of work. So if we want to extend our base factory, we can do that with subfactories or ideally with traits. And so now we get all the benefits of some prepackaged sets of attributes without polluting that base organization and creating users when we don't want to, because we're only going to use the with users trait in tests that actually need users. So how might we find existing misuses in factories? This is really fun because kind of the opposite of the tests we saw earlier, factories are kind of a single point where we can make a change and it's going to have a big impact on your code. The problem is you have a lot of factories. Which ones are the ones that are worth changing? FactoryBot offers this active support notification event that you can subscribe to. So if you want to do some kind of basic profiling, you can listen to that and log the invocations or how long it takes and find out answers to questions you have about factories in your tests. There's also the testprof gem, which comes with a factoryprof tool that will do a lot of that for you and tell you which of your factories are slowest individually, which ones on aggregate take the most time, and that can give you the hotspots to zero in on. A technique that I really like is to, if I have a slow factory and I'm not sure what's going on, load up the Rails console in test mode, make sure that my log level is set to debug, and then just create the factory in the console. And it will put all of those log messages out right in front of me, and I can see exactly what gets created, what are the queries that happen just by executing that one factory. And typically it's surprising, there's more than you think. Now let's talk about ways that your source code is making too many database calls. Active record callbacks can be really tricky, particularly when they create other records. So here we have an organization, and that organization before create will try to generate a new admin user. But then in our tests, we might want to do something like this, where we supply our own admin when creating the organization. And what's going to happen here? Because there's also a callback creating one. Well, most likely we'll end up with something like this, where we have our organization, we have the admin we created in test, and then we have the callback admin just kind of off on the side there. It's been orphaned. Depending on the order that things run, we could end up with a slightly different situation where our data is actually broken. We have our organization, and the admin that we created in test is floating off on the side. And the callback admin is the one that's associated to the organization. Now this might break your test, but more than likely it will pass and only break with a subtle failure 2 months from now, and you're going to spend a day debugging to figure out why is this not working. So maybe you know this might happen, you're a clever developer, and you decide to put a guard against this in your test. So you create a local admin in the test, you create an organization, and then you update the organization to set your admin to make sure that whatever the callback does, the one in test overrides it. Now this is the code smell. We talked about it earlier. Anytime you're doing an update to your setup data, it's pointing to some larger underlying problem. And it's possible that you need to do this because you can't refactor the active record callback right now. You're working on some legacy code, and there's a lot of other things that depend on it, and you can't make that change right now. But this is telling you there is an underlying problem that needs to be fixed, and that's creating more data than you need to. Because again, this is making 3 inserts and 1 update where we really only needed to make 2 inserts. How might we find existing misuses of data creation in our source code? This one's a little bit harder. in that places like callbacks are very centralized. So if you can fix them, it might have a big impact. But they're also very tightly coupled to the rest of your code base. And so actually making that change could be weeks of work. But pain in your tests and maybe pain elsewhere in your code will surface these hotspots for you usually. And so they're usually parts of the code that people know, oh yeah, that callback is a pain to deal with. That's the hotspot. And speaking of tight coupling, for those who practice TDD, you're a fan of the idea that your tests speak to you. Test pain tells you that you need to change the underlying implementation. And so oftentimes, if you have especially a unit test that requires a ton of setup, that's a sign that your object is too tightly coupled to other objects around it. And that if you refactor the architecture, you could have a test that requires creating a lot less data. It can also show things like depending on a callback, where it's really painful to get around it, and that causes you to create more data than you need to. And so listen to your tests. Sometimes the solution is not improving the tests, it's improving the underlying code itself, and that's what's causing extra data to be created. So we've seen 3 places where we create more data than we expect. And now we're going to look at a case study of actually digging into a code base and finding ways to improve test time by eliminating extra creates. So I had a project, and it has a very slow test suite. And I had a pretty good idea that some factories somewhere were creating more data than we expected. But this project had a lot of factories, and I didn't know which one. So I started off using active support notification with that factory bot run factory event I mentioned earlier. Built some very basic profiling to figure out how long do our main factories take. And also, not just how long does each individual factory take, but how often is it called, to get a sense of the impact it has on our code base. I ended up graphing it like this. So we have on the vertical axis how often a factory is called, and on the horizontal axis, how slow an individual run was. And then the colors and the size of the bubbles is kind of the multiplication of those two, which is just how big of an impact in aggregate does a particular factory have on our test suite. And I got really interested in that one all the way down in the right corner. So it has a big bubble, so it has a large impact. It's not called all that often, but it takes about 4 seconds to run just the factory. And in fact, I tested it in the console, loaded it up, and it takes 4 seconds just waiting for that factory to get created, which is an awfully long time. That's slower than an entire integration test. So what might be going on there? Well, I loaded it in the console and executed it in debug mode so that I can see the log of what gets created. And then those logs just start scrolling. I get pages of this. And that's when I realized, oh my, we are creating a lot of data. Something very unusual is happening here. Based off these logs, I'm trying to understand the relationships between what's going on. And so I turned to my old friend, the object graph. And a sort of simplified graph of what I was seeing looked kind of like this. I've shaded in orange the objects that I cared about for my test. And we've got all these extra pieces that come off, and there's a pattern to them. We've got this like organization with a venue and a staff, and another organization with a venue and a staff, and it just kind of repeats. So that got me really curious. What is the underlying data model supposed to be? What is the sort of correct thing supposed to look like? So then I switched to the active record models and created a good old-fashioned class diagram. And what we have is this sort of diamond shape, an organization that manages a venue and some staff, and events that take place at a venue and are run by staff. Now there's an implicit assumption here that an event belongs to an organization both through venue and through staff. It has to go to the same organization. Now that's the kind of thing that if you mess up, that might have some unexpected consequences. And that got me wondering, okay, I wonder what the factory does. And this is what the factory looked like. We create an organization with events, with, just to keep it simple, one staff, one venue, and then we create 3 events associated to it. And we can see that we associate it to the organization by connecting it via the venue, but we don't connect it via the staff. That's enough to connect it to the organization, but not having it connected to the staff means that the event factory will then go off and create its own associated staff, and the staff factory will then go and create its own associated organization, and this just keeps repeating and tiling until we have a massive tree. The solution was to explicitly set both the venue and the organization to match that same, or the venue and the staff to both match that same organization. And when we did that, the object graph of what gets created looks like this. The only data we have is the data that we want. It's all orange. So that's a win. And then came the moment of truth. Let's actually run the test suite and see if the numbers change. Because whenever you do performance work, never commit something before having measured before and after to see, did your improvements actually make things faster? And when we did, there was a 15% test speed increase. Because it was creating such a huge tree of data and we pruned that down, the tests were now 15% faster. Now, some things we learned along the way. We learned a lot of debugging techniques. We had to reach for logs, we had to reach for profiling, we had to reach for diagramming to understand exactly what was happening. The problem was in the factories, and it was just a one-line change, but there was a lot of investigation that had to go before. We had to understand how factories sometimes create more data than we expect, sometimes in a very surprising way. But the root cause in this case was that third class of problems I talked about. The underlying data model had some implicit assumptions that were not being enforced, and that led us to creating thousands of records that we didn't mean to. So in conclusion, we looked at a few different places where we can create more data than we expect, and we saw a few tips for how to keep that data minimal. Those include keeping your setup local in your tests, keeping your base factories minimal, avoiding creating data in active record callbacks, and then where it makes sense, avoid tight coupling in your code. Listen to your tests in the test pane. This is all great when you're writing new code or a greenfield app, but oftentimes we have to work with existing code. We have to find places that are already slow. And so some debugging techniques, diagramming, and particularly object diagrams, are a great way to understand what is going on, what extra data is being created. Inspecting the log, there's a lot of places you can get the Rails log, and it will show you all the queries. That's incredibly valuable. And then various profiling tools, which can be great to find the hotspots where you want to focus your efforts on more deep debugging. So thank you for coming to this talk. My name is Joël Quenneville. You can find me on Twitter at JoelQuen. I work at Thoughtbot. We are hiring, so if you want to talk to me, please do. And if you have any questions on testing in general, some of the more controversial things I talked about, or even just about creating too much data about factories, I'll be here on the side afterwards. I'll be in the hallway. So please come talk to me. I would love to hear your thoughts. Thank you.